Okay, so today we are working on these word problems. Day 1, quadratic word problems. I'm going to do 3 of them with you, and then you have 3 to practice on your own, and then we're going to finish this worksheet tomorrow. So we're not going to do it all today. I want you to please remember to round as you go. Okay, so we're going to talk more about this when we do an example together, but we need to round as we go, or else we're going to get different answers, and that's not good. Okay, a bolt falls off an airplane at an altitude of 500 meters. How many seconds will it take the bolt to reach the ground? Well, as we talked about in a different video, the formulas are these. So these are our formulas that we're using. Since my problem is in meters, I'm going to use the meters formula. And I am going to write down our information, okay? So we have a velocity and a height, okay? All right, now it says that it falls off the airplane at an altitude, so that's our height, of 500 meters. So if a bolt or something is just falling off of a plane, or something is just falling off of anything, there's no velocity. So velocity is an extra like push to get something into the air, like an additional piece to add to our gravity. So because of that, we don't have any extra velocity, any extra momentum that we're putting onto this specific bolt. Okay, so it's just falling, so we have a velocity of 0. So we use our meters formula. So our meters formula is h of t equals negative 4.9 t squared plus the initial velocity times t plus the initial height. Okay, so I'm just going to replace, keep your t's, they're like your x's. So negative 4.9 t squared plus 0t plus 500. So this means I don't have my b value. Okay, so I want to know how many seconds it will take the bolt to reach the ground. So we have our formula all set up. Okay, so figuring out how it's going to touch the ground. Let's look at a time and a distance graph. So we're starting from up here, and as time passes, this cute little bolt is falling, and then it's going to eventually touch the ground. So we're talking about this intercept, okay? I know that my x-intercept over here is more kind of dealing with the vertex if we had like negatives, but we don't do negatives in real life. Anyways, so this is my x and my y-axis. So my bolt is falling off of the plane, time passes, and the bolt gets closer to the ground until it touches the ground. So I'm really trying to figure out where my parabola, because if you could draw it, it would look like this, where my parabola intersects that x-axis over here, okay? So this is like our vertex. All right, so what we're going to do is the easiest thing to use our quadratic formula. So remember, that's x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so this is our a, this 4.9, negative 4.9. Our b is our velocity, and our c is our height. Okay, oops, oh wait, whatever. All right, so we have negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so round as you go. This guy, plug it all in. You don't really need the 0 squared, because, oops, that makes nothing. So negative 4 times negative 4.9 times 500 is equal to, and we're going to round 100th, 2 after. So this is just going to be 99. So we have negative 0 plus or minus 98.99 over negative 9.8, which is 2 times negative 4.9. Okay, so now we have two answers. We have negative 0 plus 98.99 divided by negative 9.8, and we have negative 0 minus 98.99 over negative 9.8. Now, if you know a few things, you don't have to type in this cute little negative 0. And then also, if you know something, if you don't and you just want to type them in, that's totally fine. But if you can see and notice some things, you do less work. I have a positive divided by a negative, which means my answer is going to be a negative. But this answer is not negative. He's going to be a positive x. My negative would be over here. So there's no way this will be my answer. My answer has to have the two negatives to make a positive x value so that I can figure out where my bolt lands on the ground, at what distance. Okay, so negative 98.99 divided by negative 9.8 is 10.10. So I have, oh, not distance, it's going to be a distance of 0 because it's on the ground. It's the time. So 10.10. So it says if a bolt falls off an airplane at an altitude of 500 meters, how many seconds will it take the bolt to reach the ground? My x value is my time. So I know that my x value is 10.10. My y value, my distance, will be 0 because it's on the ground. So it's 10.10 seconds. Okay, then I want to do number 2. Okay, a ball is thrown upward at a speed of 30 meters per second from an altitude of 20 meters. What is the maximum height of the ball? Okay, so let's look at this. Remember, like Hulk, the ball's thrown up and time passes, so technically, even though our ball is not making a curve, or may not be making a curve, it's making a parabola because time is passing and the distance the ball is in the air from the ground is giving this arc a height. Now, here's the thing. I know that my velocity is 30, but it says that it's not thrown from the ground. So this is not correct. Really, my picture looks like this. It says at an altitude of 20 meters. So 20 meters tall, we throw the ball, and then we have a parabola. So we want to know the height of the ball. Okay, so we can kind of use the Hulk problem. Actually, we can. Since it's meters, we're going to use the meters formula. My velocity is 30, and my initial height is 20. So I plug in my information into the meters. So I have my meters formula is what we wrote right here. So I'm taking out my velocity and my height and replacing it. So h of t equals negative 4.9 t squared plus 30t plus 20. Okay, then in order to figure out this is my axis of symmetry. I am just going to figure out my x value. So to figure out the x value, we can use negative b over 2a. So negative b is 30 over 2 times negative 4.9. And we're going to put that in our calculator. 30 divided by 2 times 9. Oh! My bad, I forgot a negative. Okay. Alright, so, let's see. My bad. This should be 3.06 because we're rounding, it should be positive. Sorry. Okay, then that's how long it took to get to the maximum height. Then I plug this guy back into my equation. So negative 4.9 times 3.06 squared plus 30 times 3.06 plus 20. So I put that in the calculator. Negative 4.9, 3.06 squared plus 30 times 3.06 plus 20. Okay, so my y value for this guy right here, my ordered pair, my x value is 3.06, and my y value, my height, is 65.92 meters. Okay, I'm going to do one more with you. I'm going to do number 6. Okay, on number 6, oh, sorry, it's kind of messy. What is the height of an object after 2 seconds if thrown downward at an initial velocity of 20 meters or feet per second from a height of 100? Oh my goodness, there are so many things. Okay, so first of all, we're using our feet formula, which is h of t equals -16 t squared plus the initial velocity times t plus the initial height. Okay, my initial velocity, it says, this is important, we'll get there, 20 feet per second. And my initial height is 175. If you throw something downward, it actually has a negative velocity, so you need to have a negative sign. Okay, so we're going to plug this information in. -16 t squared plus -20 t, you don't need that plus, but whatever, plus 175. Okay, this is our formula for the curve of this object. Now, we've been talking about heights and all of these different things, but let's see. So we are talking about a picture from initial height downward, kind of like that. Okay, I want to know after 2 seconds, what is this height? So my x value on my x-axis is 2. What will my y value be? So that's all you have to do. Just plug in 2 for t, because 2 and your x represent time. So it's -16 times 2 squared minus 20 times 2 plus 175. Okay, -16 times 4 minus 20 times 2 plus 175 is 71. I want to know the height, so feet. Okay, so you just have to figure out what you need and then plug that information in. Please let me know if you have any questions. I hope you have a great day. Bye, guys.